Hello and welcome to video lesson topic 10.6, which is circles and arcs. Arcs are just a piece of a circle. Today's learning objective is I am learning to find the measures of central angles and arcs. Now, a circle, we got a lot of key terms here, and we got a few short examples to go along with it. But a circle is a set of all points equidistant from the center. So, of course, we all know what a circle looks like. The center would be right here. And then a radius would go from the center to any point on the circle. Congruent circles are circles that are the same size, aka they'll have the same length of radius or diameter. Diameter is, you got a line segment that touches the circle twice pretty much, but it goes through the center. And we abbreviate it by the letter D. Radius is going to be letter R. This is probably stuff that you already know. Okay, here's where the new stuff comes in. Central angle. So a central angle is an angle whose vertex is at the center of a circle. So for instance, let's say we had this circle, right? And then we drew an angle inside. If its vertex is at the center of the circle, this is called a central angle. So this would be your central angle. For instance, let's call this angle AOB. Remember, your vertex has to go in the middle of the name in order to accurately name the angle. A semicircle is half a circle. So for instance, it could look like this, or if you had the whole circle, and then maybe you had some angles coming off of it. Let's say this is M, N, O, and let's say we had P down here. MPO would be a semicircle, and it's what's called an arc. So if I wanted to name it, the name would look like this. MPO, so you're like tracing it outside the circle, MPO, and then MPO, the name, just like if it was a line segment, you put a segment above it. Here it's an arc, so you're going to put an arc above MPO. A minor arc is smaller than 180 degrees. So by the way, I'll mention this here. A semicircle is half a circle. A whole circle is 360, so half would obviously be 180. A minor arc is smaller than 180. So let's say, for instance, we had circle O here, right? And then we had J and K. Notice they're smaller than a semicircle, smaller than 180, so it would be a minor arc JK with the arc symbol above it. A major arc would be, say we had that same circle, circle O, and then I put, I don't know, a Q here. KJQ looks like a semicircle, but if I went QKJ and traced that way, this would be a major arc. So let's say, for instance, QKJ would be a major arc. A major is larger than 180, so greater than 180 degrees. This one is less than 180 degrees. Circumference. Circumference is pretty much the perimeter of a circle. And it has a formula. It is 2 pi r or pi times diameter. Either one of those work. Pi is equal to 3.14 in decimal form. I'm not really sure how much we'll use concentric circles, but they're circles that lie in same plane and have the same center. So for instance, if you had like, let's say this circle, and then you had another circle out here, they have the same center. These would be concentric circles. Next, you got arc length. So this is how long a certain arc is. So we're going to talk in just a second about how many degrees an arc is. There's also how long an arc is. So the formula for that is going to be whatever the measure of your arc is, which I'll show you in a second, divided by 360 times the circumference. I know that looks confusing, but in the examples, I should take care of that confusion, hopefully. And if you got questions, just let me know. Congruent arcs are arcs that are the same length. Now, with all that information, let's do a few examples, see what we can get into. Example 1 says, identify the following minor arcs. So I'll give you a couple. Minor means smaller than 180. So for instance, AC would be a minor arc. Another one could be CE. Now there are others like AD and DE. Semicircle, so half a circle. For half the circle, we'll use 3 points. So for instance, DAC would be half a circle or a semicircle. DEC would be another one. The major arcs that go through point A. Let's see if we can get a couple. So major would be larger than 180. For instance, EAC. Now notice I left out point D, but I still went through it. EAC would be the same thing as EDC. EAC and EDC are the same because if I traced them, they're literally overlapping. So you can name it either way if you'd like. EAC. Another one could be start with point D and go DAE. That's a different one. DAE. Whoops. DAE. Sorry about that, the camera died. But what I was saying was DAE would be a different major arc than EAC. And you can see I traced them here. EAC is this one. DAC is a different one. Example 2 says find the measure of each arc. Now in my opinion, this is the easiest thing. BC, it means how many degrees is inside BC's central angle. So this 32 degrees. Mine's a little bit hard to see, but hopefully you're looking at the PDF along with this video. BD would be 32 and 58. Where I'm getting that from is what's called the arc addition postulate. It says you can add these two together to get the whole thing. So if I added 32 and 58 to go from B to D, this is the measure. 32 plus 58 looks like 90 degrees, I believe. You double check that, don't want to tell you wrong. Yep, so this is a right angle, angle BOD. Now for ABC, that is a semicircle, which we said is half the circle or 180 degrees. And then AB would be from here to here. So that's all of the 180 except for 32 degrees. So you'll have to subtract off 180 minus 32 to get 148. Again, this is how I got that. Now this, remember, was the measure. This was not the length. Example 3 says the diameter of a truck wheel is 50 inches. To the nearest whole number, how many revolutions would it take for the truck to travel 1,500 feet? Now this is a complicated question, so I need to break it down just a little bit for you. First thing we need to know is basically if we wanted to travel 1,500 feet, that would mean a revolution is going to be one circumference. So that means how many times would the circumference divide into 1,500? How many turns would it take? Because if you think about it, circumference is the perimeter around a circle. So if you were to unroll that circle, it would be however long this wheel would roll on the ground for one revolution. So now we need to find the circumference. Now the circumference is 2 pi r, or pi times diameter. Here we're given diameter, which is 50. So we'll do pi times 50. So 3.14 times 50, if I round it, gives me about 157.1. So I'll take 1500 and divide it by 157.1. Calculator says 9.55 revolutions. So we'll say approximately 10 revolutions if we were going to round. Now example 4 is going to throw you a curveball. It says find the length of the arc, leave it in terms of pi. All that in terms of pi means is pi goes in answer, not in calculator. So I'll show you what I mean. If we wanted to find the arc shown in red, which you can't really see in the book, it is this arc. So we got this circle. XY, this is a 90-degree angle with a diameter of 16. So what we'll have to do is use this formula, measure of your arc. I called it AB, but in this case it's XY. So I guess I should change that for you. Divided by 360 times your circumference, 2 pi r, or you could do pi times diameter. And if you substitute in the measure of arc XY, not the arc length, that's what we're solving for, but the measure, how many degrees is this central angle, XOY, which is 90 degrees. Divided by 360, because we're taking 90 of the whole 360, and then we're multiplying it by the circumference to kind of scale it down. In this case, the diameter is 16. Now all that means is don't put pi in the calculator. So for instance, if I were going to do this on an iPhone, here's how I would do it. I would take 90 and I would divide it by 360, and then I would multiply by 16. Notice I did not put 3.14 in there. And then my answer would be 4 and then bring down pi. 4 pi, and our units of measurement are inches. Again, this just means don't put pi in the calculator.